Hello. Hello, everyone. Thank you for joining our session. So today we're going to talk about how to make your data scientists like you and save a few bucks while migrating to the cloud. We're going to show you a little bit of the journey that Truecaller passed and how did we make our data scientists happy at the end, and we saved a few bucks. So my name is Juliana. I'm a product manager in Truecaller. I'm here together with my colleagues Fouad and Tomasz. Tomasz is a GetInData, and Truecaller is a very proud partner with GetInData. Fouad is a data engineer at Truecaller, and as I said, I'm a product manager. So about Truecaller, just to share with you some numbers. We have 210 million users every day in Truecaller. We are the global leader in caller ID and spam blocking. We were founded in 2009, so we are almost 11 years now. Our headquarters are in Sweden. We are a Sweden company, and we have offices in India and Kenya as well. We are very big in Asia, so we have we are the top 10 most downloaded apps in Google Play and Google Play Store in India. We have more than 45 languages available in the app. We have around 200, I think even more, 250 employees around the world now. So what is Truecaller? Truecaller is a mobile application. In our core business, it is to be a smart, spam-free dialer and SMS app. So with Truecaller, you can actually see who's calling you, even though you don't have this number stored as a contact in your phone book. We also have a chat, SMS, and calling options in the app, so you don't need to switch to other apps. So we are actually considered as a super app. And of course, one of our core business, it is to block spams. So you can block unwanted calls and never deal with telemarketers or anything that you don't want to actually be bothered with. We have an intelligent dialer. So actually, even though you don't have the contacts in your phone book, you can actually call people and not numbers. So you have the right to know who's calling you before you pick up the call. We also have a payment system only available in India for now. And you can basically do instantly send or receive any money using our unified payments interface. We also have a VoIP. So with Truecaller Voice, you can have free high-quality audio calls. And if you like to go spam-free, you probably will like to go ad-free as well. So we have a premium service available for Android and iOS. And in this presentation, I'm going to tell you why data is important to us. So I'm going to anticipate a bit, why do we have a big architecture? Why do we need to make our data scientists happy? So without data, we don't serve spams. So data is like a core part of our business. So our spam list is based on community reports and other aggregated data that we use to improve the identification. In product development, data is a very, very significant role in getting our product teams to develop and to understand better our user and improve the product itself. We also have customized ads. So even though if you don't have Truecaller Premium, you will be impacted with personalized ads based on the data that we aggregate and improve. And the caller ID, that's one of our main features of the app, is completely based on our internal data as well. So as you have seen, data is very, very important for Truecaller. It's part of the our business. And now I'm going to handle this to Tomasz, my colleague, that will explain you about our numbers.
So those numbers shows you amount of data we deal with on everyday basis. As Juliana said, all of the features and the application are based purely on data. So data is very important for us. Currently, we gather around 30 billion events per day. In peak hours, it's more than 500,000 events per second. So it's a significant amount. We add 15 terabytes of data daily to our storage. In total, we have 1.5 petabyte of data currently not replicated. It does not make sense because 15 terabytes will very fast get to 1.5 terabyte. We add 15 terabytes new data, and we also have some retention policies. So we remove some data, and monthly we add 4 million users. So we can't build a solution that will work now. We have to build the solution which will sustain also growth. Today, we would like to take you with us for a journey, to share the journey we made during the last few years, from data system that was barely working to the system which we have now, and we will show you in the end our future plans. So why at all we need big data and we needed a change? In 2014, the Truecaller was growing very fast. It was based mainly on relational databases, and this stuff just stopped working. There was a moment it was impossible to calculate number of active users, because every calculation, even reporting, was done on production MySQL databases. We hit capacity limits, performance limits, cost limits. It almost stopped working. So we had both volume and velocity. Those were two V's of big data. At this point, our journey, GetInData and Truecaller common journey started. So what were our goals for this journey? First is scale. The most important part was to make reporting working again, but also to keep it working as the service grows. One of the constraints was budget. Truecaller is still a startup. We are funded by external money, so we can't burn too much money. So our design choices have to be cost effective. Another important factor for us was speed. Finally, all of the tools we built are not for us as a data engineers. It is for data scientists who work with this data, for stakeholders who make decisions based on this data. So they would like to have their answers fast enough, not without need to drink too much coffee, waiting for the result. And last goal for us is self-service, like self-service analytics. It is a dream we are still chasing. We would like our stakeholders and data scientists to interact with data on their own. It is not like we don't like our work, but we would like them to work on their own without needing our help in their daily work. And I think we are getting closer and closer to this goal. And another important point in all of this journey, it fits in most of these points, is that we wanted to limit downtimes of the system to minimum. So to have the operations going smooth all of the time. So our first decisions was about such solutions, and now Fouad will tell you about this decision and further architecture changes.
Yeah, so continuing to what Tomasz started presenting, what we having the challenges and the goals. So we started the obvious things, like to discuss like what are the alternatives in the market that we think that they might fit our needs. So we started with like roughly 4 groups of data platform options. The first group is like the traditional one, which is the data warehouse appliances that are like mainly known for the banking and telco and the enterprises. The second option was to go for mobile analytics, since we also most of our data traffic is coming from the clients and from the web. So for example, like Facebook Analytics or Google Analytics or any other like cloud web and mobile analytics. The third part is like we also thought of going with the same like relational or traditional data warehouse kind of architecture, but as a software, not as a whole appliance, which is maybe one of the proper candidates are Greenplum or Vertica. The last option was to consider was Hadoop, and we know like Hadoop is like has lots of advantages, but it has lots of limitations. So after we considered all of these options and given our goals that we had regarding the budget, the scale, and everything, it ends up like we selected Hadoop for like many reasons. Then we started talking about which environment should we implement Hadoop, whether it's on-prem or in the cloud. And this evaluation happened like in like early 2014. So in these days, some with the proper like kind of implementation of Hadoop on the cloud with HDFS and Yarn clusters, all of these things, it was like more expensive to do it in the cloud than buying your own hardware and upfront investment. So we decided to go on-prem, and then we started our journey by Hadoop on-prem in 2014. So that was this was like the first kind of simplistic architecture that we had, and it was mainly Cloudera, and we have our data source coming from Kafka, and with some back-end databases dumps that we dump in a regular basis for like Cassandra or MySQL. This looks like a typical kind of architecture for that time. And we used to have the OZ with Falcon for orchestration and scheduling, and then we slowly migrated to Airflow. Also, the presentation kind of layer that we are serving the data is mainly like you have ad hocs, which can be served from Hue over Hive, or like Jupyter, you can connect to the cluster and execute like your machine learning or Spark jobs. And also for Tableau, you can have your own reports. Then after kind of couple of years, we started like rethinking, like should we still continue what we have or rethink or reevaluate? So mostly what was driving our options is like we have limitations on the current stack that we had, and also there are lots of opportunities that were not available in 2014, but they are available in 2017. And we considered like when we are rethinking things, what are the main pain point that we had, and most the biggest one is like we had a storage compute coupling, and which is what the biggest pain that we had. Like whenever we have a capacity issue with the storage, we need to buy more machines, more hardware, even we don't need compute or memory. So we just like keep paying like every like 6 months or like 3 months, we are adding more machines just like for the sake of having disks. This was the main issue, and other thing is like for the maintenance, we have our own data center, and the downtime was like kind of like big issue, and then in order maintaining physical machines is harder than having them virtual machines managed by the cloud. Also, we considered how the cloud cost is becoming, and the offering, how mature they are becoming in the data platform like stacks or tooling. So, for example, in the cloud compute and the cloud cost, we know that there is these kind of Hadoop distributions. They enable auto scaling of the compute, and they decouple the storage, and we have cheap cloud storage offerings. So this is one of the main points that we started like thinking like we should consider the cloud. Also, going forward in the strategic view, we had like know that cloud future is like they are building serverless and like managed solutions that will reduce the overhead from the development perspective. So we decided like now the cloud is an option. It was not option before, but now it's becoming an option, and we decided to go for Google Cloud Platform. So after we decided that, we started the next journey that we need to do kind of first migration, and we consider, like as Tomek said, like we don't need to go big. We need to incrementally and slowly migrate while not introducing any disruption or like downtimes. So the first way that we decided, like, since this is the low-hanging fruit for us, is like if you change Cloudera to Databricks, you will gain two big advantages. The first one is like you will be able to use cloud storage. You are able to leverage all of that advantage of the cloud storage. You don't, and also you use the Databricks for yarn compute clusters, and you'll be able to leverage like preemptible instances. You can save more cost. You can also enable auto scaling of the machines, and all of this, like for us, that are very big advantages. One of the disadvantages in this setup is like Yarn is not a good fit for multi-tenant kind of use cases with Spark. So it used to be like very good for like MapReduce type of jobs where you are checkpointing your stages every time to distributed storage. But in terms for Spark, it's not that like friendly to have it. So one of the like first tweaks that we did is like we created multiple clusters for each like kind of use case. So for ETL jobs, we have a separate cluster. For like ETL, for like ad hocs, we have another cluster. For like for each type of jobs or type of group of usage pattern, we have a different cluster, which like kind of mitigated most of the issues that we were having, the big pain points. So this move for us was like not that big, but it was like having a very big impact. Since we moved like from HDFS to GCS and it's like cloud storage, we have like some kind of comparisons that we were thinking of. How would we choose? Why would we like go for like instead of HDFS on-prem, we have already invested in the hardware and we are moving to the cloud. One of the main thing is like this no capacity planning, and you already decouple the storage from the compute. So this is the main advantage that drives us. The second thing is like maintenance. You don't need to worry about replication. You don't need to worry about integrity of the data. You don't need to worry about anything. Also, the cost is like a very big factor. Like if you think of like building an HDFS cluster on the cloud with even 2 replicas, you will be paying like 4 times the cost of cloud storage, which is like this is the list price. It's nothing hidden. Also for the speed, it's that one of the disadvantages of the cloud storage is like the metadata operations are kind of slower because each operation is done separately. It's not like how it's implemented in HDFS, and they are not implemented fully compliant API. So for us with GCS, they are having more optimization with their connectors that make them like very kind of compatible with the load pattern that we have in Hadoop. After we started, we moved to the cloud. We started feeling that it's maybe more natural to move more on to test more on the cloud offerings, what they have, and what things that we can leverage. So we started to do like kind of start to consider like BigQuery, will it fit our needs, and started doing like investigations on how it can be good, on what is the pros and cons of using this. And we did like some kind of experiments for our large kind of big use cases. And you know, like BigQuery is like these are the features that mainly define BigQuery. It's like it's very fast. It's very expensive for the storage because we are coming from the Hadoop world. It's like for us, it was like the storage is sometimes it's 30 times more expensive because we were saving the data in the cloud storage, compressed or columnar, and when they move it to BigQuery, they charge you for logical storage, which is something in memory. So that you pay off like too much. So for us, it was like super expensive. We couldn't afford it, but we were like that to the extent that we need to work around to see how can we fit it in our platform. So the first thing that we considered, like they started like last year doing this federated table support with org file formats, and they started supporting Hive partitioning with federated tables, and we did some kind of we onboarded BigQuery with federated tables because it was like for us the best solution so far. So they have it because this is federated tables is like BigQuery running on data and GCS, and GCS storage you will not pay more, so you just like pay for querying, and for querying it's cheaper for us if you consider it, if you compare it with Databricks with Hive. We did this kind of experiment, and the cost was like 2x cheaper. And if you do like BigQuery query compared to Hive on Databricks, it's like much cheaper. For speed, it was like obviously like order of magnitude of speed. Like they have like it was minutes versus hours of queries. And also for the user experience, when we started testing this BigQuery with our data scientists and exposed them to this tool, they liked it because it's serverless, it's managed, they provision the slots for us, and we don't need to just like keep it's not backed by Yarn at the end. Like you don't like need to look for like how compute you need, and you are stuck with your query because others are like querying a lot and so forth. So for a user experience, it was like very positive. We these 3 dots actually we were like spending with Tomasz like time to think of anything that can say like advantage of Hive over BigQuery, but we couldn't find anything actually. So yeah, we don't have like something that we say like Hive is better than BigQuery, whatever reason is. And finally, by the end of last year, we got like kind of negotiation with the BigQuery, and they offer us like a very like high discount if we commit. Yeah, if we commit to like 1 petabyte of storage or more, they give us like very a game-changing kind of offer. So now the storage becomes like cheap. So this is the obvious option, like to go more with BigQuery. So this is like the journey, like the last part of it. Like we think like just get rid of all of this and just like use BigQuery as much as you can, because it's now becoming affordable for us. And we are planning to, even for Spark jobs, we are planning to move most of them to BigQuery, because we knew like from our pattern of like ETL jobs, they can be easily converted to SQL ETL, and we can just leverage like BigQuery for most of the things. If we have like more complicated kind of workload or machine learning things, we can run them on Spark on Kubernetes. So this kind of, after we did all of this journey, these are the numbers of the cost, the monthly cost and effort that we are doing. So the cost of our data platform is like, we are considering one very cheap, like we are spending $6 per 10,000 users per month. This is that how we spend on our data platform. For a developer's course, it's only 30% of the infrastructure. So we are paying like X, and 30% of that X as salaries for us. And we are not that much developers, so we have 42 million monthly users per data engineer that we are handling. So we are 5 data engineers, and we are handling more than 200 million daily active users with all of their like loads and things. So yeah, I will hand over to back to Tomasz to explain to you more about how they make, how we make like data scientists happy. Thank you.
things. So all of this journey we made finally was for stakeholders and data scientists to enable them to work just easier. So here we would like to say about the most important elements of cooperation between data engineering and data science team. We think the first and most important part is support, but it's not only the one-way support from us to them. It has to be ongoing communication, the two-way one. For this, we have various tools. We use Stack Overflow for Teams. We have a lot of documentation. We have Slack channels. What is interesting, we have, for example, on-call data engineer. So data scientist, whenever he wants, can ask a question to a data engineer who should answer him immediately. The bad part of this fact is that this week I am on call, so it might be not the best SLA this week. We are also helping them with code reviews. We have forums where we share knowledge. What is interesting, it is also both ways. We have a data engineering forum where we share our plans and changes, and they have their data science forum, which we attend also. And we learn from them what are their needs, what changes they will need in near future, so we can prepare for it better. For data scientists, also flexibility is needed. I guess you know a lot of data scientists. Part of the audience are also data scientists. You have your favorite tools. We also have various data scientists. Each of them have different way of accessing data. So thanks to moving to cloud solutions, we can offer them wider methods, more methods of accessing data. One of our data scientists, for example, is a great fan of command line interfaces. He don't want to use Hue, he don't want to use Jupyter. If he has to extract data, he goes to the terminal, logs into the machine, run beeline client, the command line one, and put data in a file, and then use the CSV file. So data scientists, let's say, like flexibility, and thanks to cloud, we can allow for it. But flexibility shouldn't be everywhere. There are engineering best practices which sometimes needs to be enforced. In our case, we are trying to help data scientists to use best engineering practices with use of tools. I will show you an example of a such tool in the next slide. This tool also helps them minimize manual effort. Usually data cleaning is enough for data scientists of a manual effort. So let's not make them anymore. We help them in scaffolding, deploying pipelines, all of the CI/CD stuff, so they don't need to bother with it. So one of our data engineers prepared tool for data scientists. It is used for building Airflow pipelines. It is an interactive command line tool. You don't need any coding skills to use it. Thanks to it, we can enforce conventions and best practices and build pipelines that will be ready to deploy. Workflow with this tool looks like this. You prepare your data, your code in Jupyter, experiment with it, then you scaffold the pipeline. It's enough to type in your terminal pipeline scaffold, then you will have some interactive questions. Pipeline add some interactive questions. You are ready, you write pipeline deploy, environment, development. Everything's go to development. There you test, push for a code review. If code review is okay, everything, you get +2, you click merge, and everything is deployed via Jenkins using exactly same tool, but only changing parameter. So environment will be prod, and everything will go to the production Airflow. This one we can skip as we run out of time. So the most important points we would like to we would like to focus in this presentation. We would like you to remember is that you should always consider all choices. Don't say upfront that something is not feasible for you. even if you made a decision, rethink after some time. Maybe you can change something. Refresh your decisions, like we've done with BigQuery. We've done also same situation. We have also same situation with cloud. So maybe a decision made 5 months, 6 months ago, or a year ago is not valid anymore. Just reevaluate from time to time. And what's also important, it is better to build tools than hire more engineers. Engineers are expensive. So it's better to use them. It's better to use them wisely. But we are hiring because we need more people to build these tools. Both GetInData and Truecaller are hiring. Truecaller in Stockholm, GetInData in Poland. So if you are interested, please come to us and talk with us.
Thank you very much, Fouad, Juliana, and Tomek, for very interesting presentations. There is a lunch coming, but still, if you have some questions, so please just ask. Yes?
Okay, so this is like an inherent issue with developing in SQL, and this is kind of there is no tools that you say like this is my SQL, just test it, right? Even like for BigQuery, for Hive, maybe even in Spark you can just like use the data frames and you do your tests. But in this kind of scenarios, what we do is like we have two environments. So you do your environments. You deploy your same script. It's parameterized. Same SQL. It's parameterized to different environments. That's why we have like two environments. These SQL are parameterized, and the way that you make sure that you can make you do test. They are running and they are generating data, and you just check that in the dev environment. But for the correctness, we don't have that yet. Like you don't know like if this SQL it's generating this record, but is that correct or no? This is not, and we are like looking. If you have something like, please tell us. Yeah, I mean, this is something like it's I mean, this is like the declarative versus imperative kind of way of doing things. We are like declaring, like do this, but it's nothing that, even if you have a test, there is nothing that evaluate you. Make sure like even the evaluation would be similar to the production one. Yeah.
Yes, there is one more question.
Have you been considering switching from Dataflow cluster to the Dataflow service?
Yes, but the thing is, we have lots of dependencies, lots of jobs that are already written in Spark and in Hive. And if as we mentioned in our journey, we are using like minimal incremental changes. And now we are in the last stage that we are giving priority more to BigQuery. If you can do things in BigQuery, do it. Then we will have another consideration of Spark on Kubernetes or Dataflow. But this is like, it's not only an engineering decision, because if you change from Spark to Dataflow, you are kind of locked in this kind of ATL. It's not looking, if you move from GCS to BigQuery at the end this data, you can just export them. But if you change your ATL tool, it's kind of tricky. So you need to think of it. So we have an option that we have Spark and we have Kubernetes, which is very nice. So maybe this will be a good option for us. We have not decided. Maybe next presentation we'll say like we get rid of Spark and try the way we use Dataflow, and we are open for change, like what you see. Like we are always like rethinking.